Hello students, today we will discuss about JEE Mains 2015 physics paper. Now we will discuss all the questions one by one. Okay, let us start. Hello students, let's move to the next question. Question number 10. The question is a solid body of constant heat capacity 1 joule per degree centigrade. Heat capacity is joule per degree centigrade. Is being heated by keeping it in contact with reservoirs in two ways. So this object is actually heated in a communication with the two arrangements. First arrangement is keeping in contact with two reservoirs. So first the object is in contact with two reservoirs. Okay, one is suppose here, another is suppose here. Two reservoirs so that each reservoir supplies same amount of heat. So this supplies heat and this also supplies heat to the object. The second part is subsequently keeping in contact with 8 reservoirs. So this object is in contact with 1, 2, 3, 4, 5, 6, 7, 8 reservoirs such that each supplies same amount of heat. So heat they are supplying is same amount of heat they are supplying. So here is two reservoirs supplying heat and here it is 8. So this is the first case, this is the second case. In both the cases body is brought from initial temperature. So the initial temperature of the body here is 100 degree centigrade, here also it is 100 degree centigrade, to the final temperature. The body's final temperature becomes 200 degree centigrade and here also it is 200 degree centigrade. The entropy change of the body in the two cases respectively, the change in entropy. If I see the options, let us first solve the question and see what is the change in entropy. The change in entropy is represented by the formula. We know that the change in entropy is delta T by T integration from one temperature to the other temperature, the initial temperature to the final temperature. This is the formula of change in entropy. Change in entropy. This is based on second law of thermodynamics, and this is a change in temperature and this is a temperature. Now if I see the first part of the question, when the object is connected to two reservoirs, so and they are supplying same amount of heat, so that means in first step it has to attain the temperature of 200 centigrade. So but this expression should be is in Kelvin, so here the temperature is in Kelvin. So in this expression temperature is in Kelvin, not in degree centigrade. So the question is that in our question it is given that that is 100 degree centigrade initial temperature, so that will become plus 100, 273, so 373 Kelvin. This is the initial I value. Similarly the final will be plus 100, so it is 473 Kelvin. So we have to integrate between these two temperature limits, but then the first one is getting heat from 2, so they are supplying equal amount of heat, so the rise in temperature will also be same. So in one case the change in entropy. Next is I will tell you one more thing, that these are the important points you have to note, that entropy is a state function. It is not a path function. So because it is a state function, the change in entropy depends on initial and final temperature. I for initial, F for final temperature. So this means that in whichever way you connect, with whether with 2 reservoirs or 8 reservoirs, the answer should be same. But change in entropy in both the cases will be same. If I see the options without even solving the question, if I see the option, then these are different. These are learn to. This is same. This is different. This is different. So it should be the answer. It should be the answer, because whether the first case or second case, the change in entropy should be same, because the initial and final temperature attended by the body is same. So it should be the answer. But let us solve the question. So to solve the question, we must proceed to see. Now delta S equals to delta T by T. The initial temperature is 373, then it moves up to 423, plus it should be from 423 to 473 delta T by T. It should be the case, because the 100 degrees centigrade, that is the increase in temperature, because it is 100 degree centigrade to 200 degree centigrade, that means 50 degree increment. So 50 degree increment is done one by the one reservoir and other by the other reservoir, so 50. So this is 373 to 50. If I add 50 to this, then it will become 423. Again, this is done by first reservoir. This is the work of first reservoir. First reservoir. This is done by the second reservoir. So this is done by second reservoir, and if I solve this, this is LNT. If we solve this, I'll get LNT, and this is 373423 plus ln log T 423 and 473. If I solve this, then it is log of 423 minus log of 373 plus this here log of 473 minus log of 423. So these two will cancel out, and this becomes log of 473 minus this, so it is divided by 373. This is the answer to the first part. So delta S is this one, equation number 1. So the first part is over. Then we move to the second part, when the body is connected to 8 reservoirs. 8. So then each will contribute equal amount of heat by increasing equal rise in temperature. So the rise in temperature is from 100 to 200. That means 100 degrees the rise, and that divided by 8 reservoirs. So it is 8 1 ja 8 10 220, 8 2s are 16, 5 40, 8 5s are 40. 12.5 degrees centigrade. So each will increase the temperature by 12.5. So I'll integrate the second part of the question, that delta S is delta T by T integration from all these starting from 373 plus this value is 12 point, this is 80, then 373 and 12.5. So 5 is 8, 385.5. So this is 385.5, and plus this will start from here 385.5. Again to this I will add 12.5. So it becomes 8 9 3 398. So this will be 398 delta T by T plus, I have to continue like this for the all the reservoirs, and finally the last one should be delta T by T integration. This should be 473. Then you subtract that value 12.5 from here, so it will be 460.5. This is 460.5. I add to this 12, so it is 70 to 73. So okay, so this is how you to integrate it continuously for this is for the first reservoir, this is for the second reservoir, and this is for the eighth reservoir, because there are 8 reservoirs connected. Each is doing the same thing by increasing the temperature of the body by 12.5 degrees centigrade. So ultimately the temperature will rise by 100 degrees centigrade. Okay, but I have written in Kelvin scale because this expression temperature should be in Kelvin scale. So if I solve this, again I will get the same thing, because these other values will cancel out, these two will cancel out, and this two will cancel out. Finally this and this will remain. So it will be again log of 473 divided by 373. So this will be the answer. So this expression is same as the previous expression. You can see here this expression is same as this expression. So both the expressions are same, but then it is not matching with any one of the answers. See here in answer there is nothing else like that. Then what we'll do, that means we will write that this question is, there is a mistake in the question. So write there is a mistake in question number 10, that the temperature is in given in degree centigrade, it should be in Kelvin. 10, the temperature should be in Kelvin, that is 100K and 200K. Then solve the question. If I do that and solve the question by taking this as not a degree centigrade, but I will take this as 200K, and this I will not degree centigrade, this I will take 100K, then I will solve it, see what I am getting. So if I do that, then the first case I will have delta S, the first reservoir case, delta T by T plus delta T by T integration. This is 100 Kelvin and 100 to 150. Here it will be 150 to 200 Kelvin. If I solve this, then I will get log of 150 minus log of 100 plus log of 200 minus log of 150. This will cancel out. This will be log of 200 by 100. This is a log of 2 ln2, and this is the first one, the change in entropy in the first case. In the second case, this delta S2 I'll write as delta T by T 100. Then this 8 part is obviously 12.5, so it is 100 12.5 plus 112.5 to 125 delta T by T, and so on up to delta T by T. This will be 200 Kelvin. Before that it is 12.5 minus, so I'll write that, just that, not doing that, 12.5. So it is from here to here. If I solve this, then also I'll get log of 200, because all things will cancel out. Finally this and this will remain, so it is coming out to be like that, which is 200 by 100. So that is equal to log 2. So delta S1 and delta S2, you can see, are same. Here is log 2, here is log 2. Then in the question, you see the question paper, you will see that this is ln2 and ln2 over here, and we are also getting ln2 and ln2. So there is a mistake. The mistake is that this should be in Kelvin, not in centigrade scale. Okay, thank you.